Despite the clear signs of activity, plumes of vapor streaming outward, faint trails of dust stretching behind it like the tail of a phantom, Atlas refused to behave like a normal comet. Ordinarily, when a comet approaches the Sun and begins to heat up, volatile ices trapped within its surface vaporize, escaping as gas. These jets don't just make a comet glow, they act like tiny natural thrusters. The escaping material pushes back against the nucleus, ever so slightly nudging the comet off its mathematically perfect orbit. Astronomers call this non-gravitational acceleration, and it's so common that orbital models are built to account for it. In fact, without these subtle pushes, the paths of most comets wouldn't add up. For Atlas, however, those expectations crumbled. Its path through the solar system stayed remarkably pure, following gravity almost as though no outgassing were occurring at all. Between July and August, precise measurements showed its trajectory drifting by only 1 or 2 kilometers per day, an almost imperceptible deviation when measured against the vast backdrop of interplanetary space. That may sound like a lot, but in astronomical terms it is negligible, almost like watching a marathon runner deviate by just a few centimeters across an entire race. To grasp how unusual this is, consider the behavior of its predecessors. Borisov, the second known interstellar visitor, showed vigorous outgassing that pushed it nearly 100 kilometers off its predicted course every single day. Even stranger was Oumuamua, the first interstellar object discovered. It had no visible coma, no glowing tail, and yet it drifted tens of thousands of kilometers in ways that no purely gravitational model could explain. Oumuamua left us scratching our heads because something was clearly altering its motion, even though we couldn't see what. Atlas, on the other hand, presented the opposite puzzle. It was visibly venting gas, its jets were right there in front of our instruments, and yet the expected kick was almost absent. It was as if Atlas were governed by a hidden balance. Imagine a garden hose spraying water. Normally, the recoil pushes the hose backward or makes it snake around in your hands. Now picture a hose spraying just as strongly, but it stays perfectly still, unmoved, unwavering, locked in place by some unseen stabilizer. That is what Atlas seemed to be doing. Some astronomers wondered if perhaps its jets were oriented in perfectly opposite directions, canceling each other out like a series of miniature rocket engines firing in balance. Others speculated that the nucleus might be rotating in a way that distributed the thrust evenly, preventing any net acceleration. But both ideas strained under scrutiny. Nature is rarely so precise. Comets, by their very nature, are irregular, lumpy, and chaotic. Their jets erupt unpredictably as sunlight warms different regions, and this randomness is what usually guarantees that their orbits get tugged around. For Atlas to remain so steady suggested either extraordinary coincidence, or something else entirely. This curious balance became one of the most debated aspects of the object. Was Atlas simply the luckiest alignment of natural forces we had ever seen, a comet whose jets just happened to fire in exactly the right way to cancel one another out? Or was there another layer to the mystery, something beyond ordinary cometary physics? For scientists who had already been shaken by its strange chemistry, the motion only deepened the sense that Atlas was not playing by the rules of nature as we understand them. The contradiction is profound. If Atlas were a typical comet of its observed size, its jets should have shoved it off course measurably. The only natural way to suppress such an effect would be if Atlas were extraordinarily massive, so massive that its jets could not push it significantly. But photometric observations placed strict limits on its size. Once again, the math refused to align. Which left an extraordinary possibility. If Atlas's trajectory was not natural, perhaps it was controlled. Stabilized. Some form of mechanism counteracting the jets. The notion sounds like science fiction, but when every natural model fails, the door to stranger explanations creaks open. Even the way Atlas was discovered reveals how close we came to missing it. TESS first captured it in May 2025, buried in the crowded starfields of Sagittarius. At the time, its motion was so subtle that automated systems dismissed it as another background star. Only weeks later, when the Atlas survey flagged its unusual brightening, did the object's true nature come into focus. Astronomers and amateurs alike scoured archival data, reconstructing its light curve from months of overlooked images. The story of Atlas was not a sudden revelation, but a puzzle pieced together slowly, observation by observation. Catching any interstellar visitor is astonishingly rare. For every 100 billion comets orbiting the Sun, perhaps one or two originate from another star system. Each detection is like winning a cosmic lottery. But unlike a radio signal that fades instantly, an object carries its secrets with it. Its chemistry, structure, and orbit endure, waiting for us to uncover them. Now, Atlas joins an exclusive family. Oumuamua, the mysterious 2017 object with no coma and unexplained acceleration. Borisov, the 2019 comet that behaved exactly as a comet should. And now Atlas, an active body with visible jets, yet an orbit nearly untouched by them. 3 visitors, 3 different patterns, each challenging our assumptions. The universe, it seems, delights in contradiction. Across the globe, telescopes both professional and amateur are tracking Atlas with unprecedented intensity. The Rubin Observatory in Chile is capturing high-resolution images. The LSST survey is monitoring it nightly. At the same time, amateur astronomers with backyard telescopes are contributing crucial data. Open-source software allows these observations to be combined, producing a continuous global record. Never before has the search for cosmic mysteries been so collaborative. Bit by bit, scientists are narrowing the possibilities. Instrumental errors have been ruled out. Calibration mistakes corrected. Models of cometary outgassing tested and discarded. What remain are the anomalies themselves: an excess of nickel, an absence of iron, a 5-fold surge in brightness, and a nearly perfect gravitational orbit despite visible jets. Each clue deepens the puzzle. Perhaps Atlas will ultimately be explained by a natural process we have not yet imagined. Perhaps it will force us to rethink how comets form and evolve. Or perhaps it represents something more radical, evidence that intelligent civilizations may leave behind not just signals, but artifacts, durable messengers that drift silently across the stars. This is where Atlas pushes us to expand the search for extraterrestrial intelligence. For decades, SETI has focused on listening. But Atlas reminds us that listening is only part of the equation. Intelligent life may leave evidence not in broadcasts, but in matter, artifacts that survive for millions of years, carrying their story not in words, but in their chemistry and motion. Signals fade. Objects endure. And sometimes, those objects may be the true messengers of the cosmos. The case of Atlas is far from closed. It is still moving through our solar system, still being tracked night after night. Each new observation could change the story. A single unexpected outburst, a strange chemical line, or a subtle orbital shift could alter our understanding forever. This is science in motion, an unfolding detective story written across the sky. The mysteries remain unresolved. Why nickel without iron? Why such a surge in brightness? Why jets without drift? These are not small inconsistencies. They are clues pointing toward processes, or perhaps even possibilities, we do not yet comprehend. And in those unanswered questions lies the real power of discovery. Atlas is more than just another comet. It is a test of our imagination, our patience, and our willingness to expand what we consider possible. It is a reminder that the universe is not silent. It speaks through signals, yes, but also through objects, relics, and anomalies that force us to question our place within it. So keep your eyes on the sky. Follow the reports from observatories. Participate in the hunt if you can. Because the next interstellar visitor could arrive at any time. And when it does, every observation, every spectrum, and every shared discovery could bring us closer to the answer humanity has sought for so long. Are we alone?